we operate the biggest, smartest network of internet sensors in the world. And this gives us unique visibility into all the traffic that's in the internet, both benign and malicious activity. And it equips our customers to eliminate false positives and understand what threats are targeting their organization. So some of the ways that people will apply gray noise data and the SOC, we get used for alert triage and to just automatically reduce alerts to help the SOC analysts that are just absolutely being bombarded with alerts and some of those being noisy. For incident response, also, we help accelerate investigations. We have a lot of tools to help you analyze like large chunks of logs and data. Threat hunting teams will use this to reduce noise and filter through NetFlow searches faster. Because we listen to all the scan and attack traffic, we also can let you know, hey, which vulns should you prioritize? Is it being exploited in the wild? At what scale and by who? And then we can give you some tools to mitigate the risk to your organization in the interim. So yeah, that's just a quick TLDR on what gray noise is. For anybody that is new to the chat, you guys have an understanding. And providing actionable data from what our sensors collect for these use cases is hard. And Daniel is going to walk through one of the tools that our team uses internally to do that and more, and like things that we might make available to you later. So some background on who's going to be presenting. So this is the most you're going to hear me talk. Daniel's going to be doing most of the talk. So he is a principal data scientist here at GreyNoise. Daniel has a long history building cyber tech that uses supervised, unsupervised machine learning and artificial intelligence. And in the words of our CEO, he is a big stats guy, big data guy, an avid computer hater, and he is not an ivory tower schmuck. So those are Andrew's. That was Andrew's introduction for you, Daniel. But yeah, so I'll hand it over to you and let you, take it away.
Perfect. Thank you so much, Abigail. So yeah, we're going to be talking about a tool or a product that we've been creating internally that we want to be exposing externally to users. And I think this is going to be something that's going to be very, very useful for perhaps your organization, depending on like your needs. But it's a very, very useful thing. We're going to start off just going down the list of what's the problem we're trying to solve, what is our solution, how it works, and then we do some demo and some future capability stuff. So the problem is, and this is a problem that you probably have in your organization, you have too much data to look at, and you can't really like go through it all. So GreyNoise, we have like a global honeypot network, and we see like 2 million HTTP events a day, and that's just like one protocol. That's just HTTP. Like there's a whole ton of data behind that. We have a lot of like automated processes that we do. We have like over 1,000 tags to say like, oh, this is a particular type of crawler. This is a particular type of exploit. But there's a lot of things we don't tag because like the evolution of attack versus defense is an ongoing problem. And there's a lot of mutations on things that we do tag. So those things like keep on coming. So the problem really is we need to reduce the space that our human analysts need to work in. And you probably have that same problem. Plus, like you have 1 million alerts a day, and you can only look at like 10, 40, 100 of them, something like that. And then while we were working through this, we were thinking like, what other bonus problems we could solve? So finding like targeted traffic, so maybe stuff that's just on your network, or finding like 0 and end days that are happening in the wild, and then automatically creating detection and blocking rules, which is like super important. It might be like the next generation of security. But like all these things, we have to figure out where the data is, how we can consolidate that data, how we can analyze that data and do that. So that's like the problem that we were sort of forming around. So Sift is our solution to that. It's at least a partial solution to that. And this is a super buzzwordy version. And I will appreciate you all to roll your eyes while I speak through this. It's a completely automated triage analysis tool that finds new and interesting HTTP traffic that's hit like GreyNoise's global distributed honeypot network. It uses custom LLMs, machine learning techniques, a whole bunch of stuff, experimental GreyNoise features, and it creates a daily report. So the difference that I like to make for this, outside of the buzzword version, is that we use the right tools at the right stages of the problem to make something that's not a gimmick. This is actually important because you've probably seen a ton of AI tools that like look like they're cool, and then they fail when you try to actually use them, or they in your industry setting they fail when you try to use them. They're really cool when you want to do like image generation or something like that, but like when you're trying to solve a business problem, it's really really bad. So we're trying to use the right tools at the right stage, and not just like jump on the AI trend to say like we can solve everything here and in one stop, because that's not how it works. But we want to tell you how Sift actually works, so we can build that confidence that you would have in us. There are three steps to this. One, we collect the data, filter data, and analyze data. And anybody that's in this process, this is basically like the ETL pipeline, that you know, you love, you hate, or whatever. But this is part of the process of any like data processing pipeline. So one, our collection, we have a huge global distributed honeypot network to collect all this data. We have 30 plus providers. These are like cloud service providers. So think AWS, think GCP, think PQ hosting. Like we have regional providers all over the place. And then we have over 100 regions within those providers. So we're like literally all over the place. We have tons of sensors everywhere. And we also have something that's new, that's like user deployed sensors, that is really, really interesting. And you could easily deploy these things in your network. And one of the cool things about it is that the traffic just sort of bounces off of these sensors on your network and then comes to our network, where we have emulated personas, where some of them are shallow. They just like show like, here's like what it looks like. Some of them are very complex. So we can have like Microsoft Exchange sensors, CTE routers, all that sort of stuff. And you can just like forward traffic over to that, and it looks like it's on your network, and we can collect it, and it has no threat process on your network. And we just get all that sort of data to see like what people are trying to do on your network, which is like, I don't want to diminish this fact. That's like a super cool thing that we can actually do now. And this is still like early access, so like hit up Abigail for more access to that. But this is something we can do, and that expands our scope of knowledge. So when we talk about like how we can compare information of a global honeypot to your specific network, we can actually do that. And so that gets a little bit into like the filtering step. So we have Sift. So we have this access to a lot of information that's too much information for anybody to like think about and work about. You're not going to like step through like 2 million HTTP requests. Like that's not a daily operation. But what we can do is we can use a custom language model that I built, that we can we can encode all those sort of HTTP payloads with a bunch of stuff like taken out that like messes with language models, because like random strings and common user agents and all that sort of stuff, that doesn't really work well. And I can get into the technicals of that offline with anybody that wants to have a conversation about that. But we can take all that, and then we have like our entire HTTP data set, 2 million samples per day in vector format. And if anybody on this call is a machine learning or data scientist person, that's a gold mine. So there's some really, really cool things we can do with that. And so one of those is to create like this historical baseline. So we can take a bunch of like old data and put it into an approximate nearest neighbors index. And then we have like this source that we can query against that says like, if you have a new piece of data, is this thing like similar to something we've seen before or not? And so this is like a really key idea, that we can say a new piece of information is worthwhile to look at versus it's the same thing that we've seen before. Um, and so that's one part of it. The next part is like clustering data. And this is more just a procedural thing to say like, hey, here's some new data that we want to look at. We want to like not query a million times. We want to do it like right now. Um, and so we can take all that clustered information and then filter it through that historical index that we just created. And so now we have like 100 new and interesting samples that like we want to look at, or we want a human analyst to look at, versus the 2 million samples that we saw all day long. And so this is like a manageable payload that we can work through. And because our design team is awesome, they made this little thing for us. So this is sort of like a visual representation of what this is doing. It's taking all the stuff that you don't really care about, like the get index.html or the post API slash register. But it is finding this one thing that is like a path traversal, trying to find like console portal. And it's finding that one thing that like you might be actually interested in. And so once we have that cool small set of information, we wanted to go a step further, and we wanted to see if we could use like the actual new LLM and AI technology to make this more accessible to a wider audience, and to make it a more like make it actually triageable, if that's actually a word. I might have just made that up on the spot. But we want to take like these payloads that we're having and feed them through like commercial LLM, and to like get the analysis that we want. So there's a lot of like behind the scenes work that goes onto this, like prompting and checking, because you can't trust these results. But we do a lot of background work to make sure that it is more trustworthy. And we generated a JSON report, so we get like an analysis that has like this the plain text of like what is this thing trying to do. We get a threat score of like how bad is this, how much should I like pay attention to it. We get confidence in our own analysis, we get keywords, we get SQL and Suricata rules about like how we can actually turn this into a queryable product. And then we also, like, since we're GreyNoise and we have like this giant set of information, we can create our own APIs and even some of our experimental products, and say like, what are the tags that we have associated with this actual event? So that's like that's pretty cool. And we have like the ability to scan back at an IP that has scanned us. And so we know like what they're doing, what they're presenting themselves as. We have geo information. We have like tons of other information. And so we do that. We do all this sort of like reporting for you, and we collect it all into daily reports. So you can have like, here's what happened today. And so like in the morning, you may be sipping your coffee, and you just want to like look at this report and see like what happened on the internet yesterday. Like what was the big deal, and are there things that I should really be concerned about? And so this is like something we can provide. And yeah, to tease the story later, this might be something we can provide specific to your network. And that might be a lot more value than just like, oh, you're curious about what's happening on the internet. But we'll get into that too. But just like in general, like how Sift works, we provide all these sort of things. Like, so there's the threat and confidence score and all this sort of stuff. We provide payload examples, tags, and analysis. So this is a whole sort of like example, and I'm gonna transition into a demo. So Paul, or just take with me while I move into another screen share.
Yeah, and while you do that, Daniel, somebody just shared something in the chat that I really liked. They said, GreyNoise Sift, it's your internet morning news. I'm going to
Yeah,
share that with our product marketing team. Um, yeah,
I
I
would I
wonder
would
if
love
it's,
that.
I wonder if it's something that Glenn, so we have Glenn, he heads up our research team. He has something that he posts online that's called, he has a hashtag for it, but like, what caught my thready eye this with my morning coffee or something. I I
Exactly.
I think he probably uses Sift to kind of do that. So yeah, you're right on the mark, David. Thanks. Continue,
Yeah,
Daniel. Sorry.
yeah. Glenn uses Sift, and he uses our trending page for that, which is really useful too, because that measures like for the tags that we already have, what's popping off. And you'd be surprised at what comes out of that, because sometimes it's like an old vulnerability that we had, and then like it's being used like 100 times. So, but just a quick demo, and we're going to do like another little demo after. But looking at some stuff that we just had on a couple of days ago. So this was 12/11. We have a potential directory traversal exploit. We have a threat score, confidence score, attack type, all that sort of stuff. We have an example of the payload. You can see from this little bit of information in the payload, these are encoded slashes. So this is like a path traversal attack. We have a little bit of a snarky response that we generate for that too, and we have analysis. And so we do this every day for all sorts of stuff. So the next one is a potential cross-site scripting attack. You can see somebody really likes the leak thing. But we have like tons of these, and this is like another one. And we have like a Java attack, I think, and this one, JavaScript, yeah, we have tons of stuff that we're just like uncovering, and this is all out of entire like global network. And I'm going to skip ahead of my slides, but actually talk about something that I'm gonna like show slides later. But imagine if we went back in time and looked at when Log4j happened on December 10 of 2021. We ran the analysis on this, and it was like really really cool because we detected a ton of Log4j payloads without actually knowing it. And so there, like I had mentioned before, there are a couple of parts of like this analysis. One is finding new stuff. One is doing the analysis of that using like OpenAI's LLM product. But for the analysis part, that doesn't know anything about the history. So looking back in time is the same as if we would run it today. So we would have, we can look through this. There are 20 different instances of a JNDI LAP or LDAP like exploit that are happening here. So those are all identified. It lit up like a Christmas tree when we actually had like one of these global exploits. So these are things that we can actually like find in the middle of when they're happening. And there was also the day before any of this happened, I think, if I can find it. Yeah, there was one of these here too. So before like it was even released and publicized, we found an executable attack. So that's I think a pretty cool thing that like this thing can do, and it's indicative of what it could do on the next attack. And I'm going to go back to the slides now. Sorry for jumping around screen shares. Sorry. All right. So in general, if you want to check it out yourself, we have some stuff open. You can go to sift.labs.greynoise.io, and this has everything. So it says the last month of data minus the last 7 days, and it's accessible to anybody with a free GreyNoise account. Um, we reduced the last 7 days because we do actually see like some zero and end days, and we want to be cognizant of those before we release everything to the public. So we are a little concerned about that. And if you want to inquire with our sales team, there's a lot more access available, and we have a lot more stuff that we can start to talk about. I just showed like that example use case for Log4j. What's kind of interesting is if you've been paying attention lately, Lazarus Group has been like doing new Log4j stuff, and we've been catching those too. So this is not just a historical example of what we could cop. This is like we're catching things in real time that are like important to companies. And we have some pretty cool future capabilities that especially if you want to work with the sales team and figure out how you'd want to use this service. we have some that we're working on right now. So not everybody wants to use just like the UI. So we'll have API access. That's basically built. We just have to expose it. And maybe you don't care about like WordPress vulnerabilities or a specific type of attack. So we're having it where we can make it filtered to specific technologies, attack types, and even a MITRE attack framework. And it's like, actually, after this call, I'm going to be like trying to like work the MITRE attack framework into the product. So that's like really happening soon. And then sometimes you don't want to like look at a feed every single day. So we want to make it easy to search. So you don't have to like just like go through the entire like list of things, but maybe you have something in particular you want to look through. So that's like an option. And we're improving like constantly. We're playing sort of fast and loose with the cutting edge AI models. Those are changing quickly as well. And some of the items that we are presenting are not as solid as we would like them to. So like for the CVE guesses that we have, I built a whole sort of RAG, retrieval augmented generative search process based on like the NIST like CVE database. But that only works like so well. And I'm trying to improve that. And there's also for rule generation, where we're like, we have like some generative approaches to that, but we want to do something more robust. And we're working on a lot more of like the classical ML and direct logic approaches to like confirm and improve these results. Because like this is going back to the point I mentioned where we're not trying to be gimmicky, we're trying to be product usable solution. And this is where it really hits the road, where we have to make sure these things are solid and not just like, well, the AI said that, so whatever. So like we treat the AI and LLM as a jumping off point, not as a landed solution. And I think that's a big point that, you know, is important for our product and for our customer base. And then a couple other things we're doing. We're trying to do more protocols. Like this was all based on HTTP, but there are tons of other protocols. We want to do stuff for SSH, for SAMPA, for like a baseline model, perhaps. So we can just try to find all new and interesting data. We have plans for like making specific reports just for your use case, on-demand slices of data, all that sort of stuff, and maybe better detection and blocking rules. If this works out, which like we have very positive indications that this is working really well, this is basically like the antibody system for the internet. So this is like a kind of weird philosophical point on it, but we can see stuff coming in and automatically create rules to block that stuff that is bad. And this could be a very, very interesting phase of how we do cybersecurity in the future. But that's all like me being a nerd and thinking about things. And I think that's it for my talk. I know I took up a lot of time and I hope people enjoyed it. And if anybody has questions, I would love to answer them.
So Daniel, I'll start with a fun question first. If you can roll back up to that first slide with your picture on it, someone wants to know, is this a downhill racing tyke?
No, this was my I think my niece's trike. This was back at home. I'm from Georgia, and this is from our family home in Georgia. And the sun just hit me in the right way, and I just love the picture.
Well, let us know if you ever decide to take that down a massive hill. I'd like to see how that would go out. Okay, a couple other like product related, or I guess like actual like presentation related questions. I had somebody ask, how do you encode your data?
Yeah, so that's a really cool question. So what we use, there's been a lot of talk about like these large language models, and some of them are useful for specific examples. One of the things we found really useful was using a BERT, and that's a bidirectional encoding representation with transformer model. Like that's a whole acronym sort of deal. But a BERT-based approach to try to encode HTTP data, because we already, and I can share links to a blog post that we have on this. We know the full set of data, and we can like make that encoding better. The things with GPTs are trying to predict the next word, and that is useful for the generative part of it. That's why the G and GPT comes from. But for our purpose, we know the data that we want to look at. So we want to find how that's encoded. So we can make something that's smaller than like these super huge models that have to run on these giant GPUs. And we can make something that runs on like a commodity GPU or on our side. And it works really well for just encoding that data and making comparisons against that data. So it's a BERT-based model, and I can link to a blog post that tells you exactly how to do it with the code actually to do it yourself.
Cool. Then the only other one we have left, and so I'll open it up, like speak now or forever hold your peace if you have any questions. But it's just on average, like how many samples do you see a day?
Yeah, so we with the total telemetry that we're collecting from GreyNoise, we see like over 2 million samples of HTTP events. But when we condense it down and like find the new stuff, we're really looking at like 30 or 40 events a day that somebody has to look at to say, like, should we analyze this? Should we make a rule for this? Should we investigate this further? And so that's really where the power comes from, because it's a 5x, I think, is like crunch down into like how much you need to actually look at. So that's been super useful for us internally. Our team, that is the detection engineers on our team, they were writing 2 to 3 tags per week sort of deal. Now they're writing 5, 6, 7 tags, and there's a backlog because we have all these new things that are automatically identified. And previously you were looking on like forums or Twitter or any other sort of like thing to try to find like, okay, what's the new threat? What do I need to look at? But now we have this automated internal system to say, this is what's new, this is what's important, and this is like 80% of the solution to get you there. And so that's what we're trying to transfer to other companies, because I think that'd be useful to everybody.
Yeah, I love that. Yeah, I think one thing that you mentioned earlier in the presentation was just that you wanted it to actually be like work when applied in the real world, and we're eating our own dog food, right? Like this is something that we're using internally and seeing great benefit in terms of like worker efficiency or researcher efficiency. So yeah, so just to wrap up, right, we're a little over time, but just to mention, right, like if you the holy grail is going to be when we're able to offer customer hosted sensors with oh wait, one more question before I go into this. We mentioned emulating different device types. About how many different types of devices and how much work does it entail to make new ones?
That's a great question. So we have about 25 that we currently host. And there are different levels of emulation. So some are very shallow. So it's just like, we put up the banner, and then you like interact with that, and we just collect that first piece of data. There's some that we have full device emulation on, where you're interacting, like you can like potentially compromise the device if there's something we haven't like thought about. But like we're full like emulation on that. Those are different levels of complexity, obviously. And those would have to come with like, if you really wanted that, you might have to pay for us to like actually do that, because there's like some human cost to like make that. But we have a bunch of stuff now. Yeah, like I said, I think 25 plus things that we did, and we have the process to keep on adding more to that. So we're just going to be increasing our repository of potential devices that you could emulate.
And do you know off the top of your head if Soho routers are in our list of
I don't know off the top of my
personas?
head. I'd have to
Yeah.
look.
I was trying to check our things to see, but um yeah. I know other people have been asking about it, so
Yeah,
um
it's probably on the list of, if it's not there, it's on the list of to do.
yeah. So, but yeah, that actually question curtails really nicely with what I was going into with like the ideal end state, right? Sift is a really cool tool. Like it's good for our researchers to sift through our data to develop new tags so we can tag more of the traffic that's hitting our sensors and provide you with context and insight around what they're doing. But the end state is that customers will be able to host GreyNoise sensors on their own networks, and route that traffic back to us and have it run through our analysis engine. And then in that like ideal state, right? Like you'd be able to use Sift on your own honeypot data, and then talk about like future ideal state. People would be able to contribute their own tags to it. And in terms of like personas, I did just get confirmation from our CX team, thanks Hilaire, that Soho is not currently on our list of personas. But when we're rolling out this, customer hosted honeypot capability, there will be options where you will have different persona libraries that we're constantly building out, but you'll have options where you can like pay to have GreyNoise make your own make a custom persona for you. And that's part of some of our like broader, just like more in-depth uh, Intel offerings. So that is the end state, but I know Andrew, like you're not the only one to ask about Soho routers. So hopefully we'll see that pop up in just some of our basic persona libraries, but there will be differences between like what's available to existing GreyNoise customers and what's available to community users in terms of, like what's per persona or what uh yeah, like how many different personas and what type of personas and what level of emulation would be available. But our goal is to make it so that there is some level of sensors available to all users. It just might take some time. And so we're prioritizing those paying GreyNoise customers first. But eventually it'll be open, for the community because we want to feed our community. So